Okay, so we're doing phylum Arthropoda now. So phylum Arthropoda is by far the largest group, the most successful group, and not just by a little bit. It's huge numbers that we'll talk about in a second. We've talked about some of their relatives, the onychophorans, which are the velvet worms, and the tardigrades. But now we're going to talk about the arthropods themselves. So Arthropoda means jointed foot. They're the largest phylum, like I said, not just by a little bit. They're by far the largest phylum. And they include insects, spiders, crustaceans, millipedes, scorpions, ticks, etc. And the etc. is a lot of stuff you probably haven't even heard of, probably a lot of stuff I haven't even heard of. So they're, like I said, a huge, huge group. How big? Let's take a look at this. So this is the chart of all the different species of animals. We are in this slot, the vertebrates. This is fish, amphibians, reptiles, mammals, and birds are all in this slot. Mollusks are here. All the other invertebrates are here at 5% of the animals. Arthropods altogether are 84% of all known species of animals. So if you grabbed 4 animals at random on the earth, 3 of them are probably going to be arthropods, a little more than 3. Of those, about 8% of the animals on the planet are spiders and their relatives. 3% are the crustaceans. Insects are 73%. 73% of all the animals on the planet are insects. 900,000 species of arthropods that we know of. And again, that comes to 84% of all animals on the planet. Why are they? They're the most successful phylum, but why? First of all, they're ecologically diverse. They're found pretty much everywhere. Let's see. Someone said they can barely hear me. Let me see if there's a volume control. Built-in microphone, audio settings. My microphone's turned all the way up. I'll try to talk a little louder. Automatically join. It's a speaker volume. Okay, so I have one person says it's going in and out. Someone else says they can hear me fine. So Phoenix, that may be your connection, not mine. So we'll see how it goes. Okay, so they're the most successful phylum. They're present in all regions of the earth. They're in the air, on land, freshwater, marine environments. You can find insects drifting in the air higher than jet planes usually fly. You can find them at the bottom of the Mariana Trench, not insects, but arthropods. You can find them on land. The largest land animal on Antarctica is a very tiny insect. They're basically everywhere. Okay, so characteristics of arthropods. They have a segmented body, jointed legs. So the Panarthropoda had the segmented body. They had legs, but they weren't jointed. And now you can see, looking at the crab, the legs are very jointed. They have an exoskeleton. The exoskeleton is a hard shell. Your skeleton is inside your body. You have an endoskeleton. They have an exoskeleton. And like the Panarthropoda, they have an open circulatory system. Okay. Remember, open circulatory system means there's no arteries and veins. Why are they so successful? Well, first of all, that exoskeleton is very versatile. It can be changed into many, many different shapes. Just two examples, you've got the roly-polies and a spider. Very different shapes, but the same type of exoskeleton. Very efficient locomotion. A lot of arthropods are super fast. Try to snatch a fly out of the air when on a warm day sometime, or try to stomp on a cockroach that's running away from you. They are very fast. Go outside and try to catch a grasshopper. Air is piped directly to the cells, which is a lot more efficient than most of the invertebrates. Highly developed sensory organs. So not only are they fast, but they can see you coming. And some of them have a very complex behavior. And we'll go over all of these. So the exoskeleton, it's external. It's not enveloped by living tissues. Let me see. Okay. It's made of chitin. Chitin is a material. You've heard about it in video games sometimes. I think I just totally went blank. The Elder Scrolls, you can get armor made out of chitin from really large insects and stuff. It's a protein that is made by the insect or the arthropod of whatever kind. It's used for protection. It's secreted by the underlying epidermis. And in terrestrial organisms, it's a waterproof barrier. And this is where the muscles attach. Your muscles attach to your endoskeleton. Theirs attached to the exoskeleton. Okay, so arthropods are what percent of animal species? Okay, so the correct answer is 84%. Huge percent of animal species. Okay. So the exoskeleton, depending on the animal and where they live, can be soft and permeable or hard and impermeable. Between the segments of the body and the appendages, it's thin and flexible. If it wasn't thin and flexible where the appendages were, they wouldn't be able to move at all, right? Now we've talked about with the panarthropods, all of them have to shed their skin to allow growth. This is termed ecdysis, is a fancy term, and we're going to pretty much just say molting. So they don't grow until they shed their skin because that exoskeleton doesn't grow. It'd be like if you put on a suit of armor that fit you when you were 3 years old and you can't take it off. You can't get any bigger with that suit of armor on. So they don't grow until they shed their skin. And when they shed their skin, they can also regenerate their limbs. So if a leg is lost on a young arthropod, the next molt, it can grow back. Now, this doesn't happen with a fly, say, because once an insect has wings, they're never going to molt again. And so if you catch a butterfly and tear off a leg, it will not grow back. But crabs, if they're not full grown, they lose a leg, they'll grow a new one. So the exoskeleton is relatively heavy, and that limits the size. I'm going to tell you a couple of things about arthropods today that tell you why we don't have spiders the size of cars, and the movies where the giant spiders are taking over the city can't work. The exoskeleton is too heavy, and it gets heavier in proportion to its size. So you get if you got too big, the exoskeleton would be so heavy they couldn't even move. You've probably seen these exoskeletons. This is a cicada, or a locust, some people call them. They live underground for most of their life, and then when they become an adult, they climb out of the ground, anchor themselves to a tree or a fence post or the side of your house, shed their skin and leave the skin behind, and then they will come out, their wings will come out, and then they'll be able to fly around. So here's some gifs of a scorpion and a centipede shedding their skin. Here's a crab doing so. And here's how the growth works. So this crab stays this size, doesn't grow at all. Not like us, where when you're growing, you grow a little bit each day. They stay the same size until they shed their skin, and then they grow a lot. They can be a lot bigger. And when they shed their skin, this exoskeleton is left. And a lot of people that have arthropods for pets, whether it's a hermit crab or a tarantula, they'll get scared that their pet has died because they'll come in and the exoskeleton is laying there, not moving, sometimes upside down. And what happens, though, is when they shed, their skin is very soft for a couple of days, and so they hide. So they'll shed their skin, leave their skin out on the open, and then go hide, and you come in and all you see is the shed exoskeleton, and you think it's dead. I don't know how many times I've had people come to me and look at my aquarium and say, "Oh, your hermit crab died." And no, it's still alive. It just shed its skin, and it's hiding, and all you see there is the skin. Here's a video of a spider crab shedding its skin. You see the carapace is lifted up, and this pink soft stuff is the new shell. They sped this up a lot, obviously. You see now it's actually coming out. You can see this area. It's much bigger than it was. Then it starts to pull the legs out. And there it is. And like I said, it's going to be very thin. This exoskeleton is going to be very soft and flexible here. It's going to take it a couple of days to harden. So they'll usually find somewhere to hide. And you've got the exoskeleton left there. Okay, so what is the exoskeleton made of? There you go. Oh, still haven't launched it. There you go. Hey, 3 of you haven't answered, guys. All right, so the correct answer is chitin. Calcium phosphate is what your skeleton is made of, not theirs. Okay, air is piped directly to the cells. This is more efficient than most other invertebrates. And the way it works is they have a very efficient tracheal system of air tubes if they're on land. If they're in the water, they breathe by gills, of course. And they don't breathe through their mouth. Their mouth is not connected to the respiratory system at all. They have a series of openings on the side of their body, and those lead to tubes that go into the body, and that brings oxygen into the body and releases carbon dioxide. The blood is sloshing around, bathing all of these trachea, and that's where the absorption and release of oxygen and carbon dioxide takes place. This also limits the size. This breathing system does not work on a really large animal. There's no way they can get enough oxygen to the body. So this is another reason we don't have grasshoppers the size of cars and things like that, which in my opinion is not a bad thing. They have highly developed sense organs. They have sense of sight, touch, smell, hearing, balance, chemical reception. Some of them can taste with their feet. Some of them have many eyes. They have these very complicated compound eyes. This guy here is a mantis shrimp, and they have the most complicated eyes in the animal kingdom. So think about our eyes. We can see red, orange, yellow, green, blue, indigo, and violet. Anything past the red side of the wavelengths is infrared. We can't see that. Anything past the violet is ultraviolet. We can't see that. This guy can see infrared, ultraviolet, and polarized light. So it can see way more frequencies of light than we can. They also have complex behavior patterns. They can do complex organized activities. It may be innate, which is inborn, unlearned, instinctive, or it could be learned. Think about bees. Bees can make a hive, which is pretty amazing in itself. They've got, they make the wax. They turn the wax into these cells. They collect pollen and honey, nectar to make into honey. They have to do several different things to do that. They raise the babies in here, and they can even tell each other where the flowers are. They do a dance called a waggle dance, and scientists have actually made little robotic bees that they can put into the hive and make them do the dance and tell them exactly where they want them to go. It's very specific, so they can tell each other exactly where the new batch of flowers are. How does oxygen get to the cells in arthropods? Okay, go ahead. Okay. Correct answer is the system of trachea. Very good. All right. So the groups of arthropods. We've talked about the taxonomy of animals. We've talked about this a lot. You have kingdom, which we're doing animals, so kingdom Animalia, phylum, class, order, family, genus, species. We've talked about several different phyla. We've talked about the 3 different types of worm phyla. We've talked about the mollusks and the sponges, the jellyfish. All of those are different phyla. Well, after phylum, you have class. If you've got something you want to put in between, they put subphylum. And so here's several subphyla that we're going to talk about. This is smaller than a phylum, but bigger than a class. So there's subphylum Trilobita. The trilobites are extinct now, but they were very, very common on the planet for a very long time, hundreds of millions of years. Subphylum Chelicerata. This is a very diverse group, which includes horseshoe crabs, spiders, ticks, mites, and of course some extinct groups. Subphylum Myriapoda. The myriapods are the centipedes and the millipedes. Myria means many, pod means foot. And subphylum Crustacea. These are the crabs, lobsters, shrimp, barnacles, all of those types of things. Crawdads, crayfish, however you want to call them. And finally, subphylum Hexapoda. Hex means 6, like in hexagon, pod, foot. These are the insects. All right. And the number of legs is a good way to tell some of these groups apart. They have a ton of legs. It's probably Myriapoda. Most of the crustaceans, or a lot of them, have 10 legs. The spiders, ticks, and mites all have 8. Horseshoe crabs are different. But anyway, here's a little bit about the trilobites. This is from Walking with Monsters, from the Walking with Dinosaurs series.
Nothing yet lives on land, but in the ocean, it's a different story. Life has already been evolving for millions of years at a slow and steady pace. The seas are full of simple, soft-bodied creatures blindly drifting in the currents. Now, however, in the coastal shallows below, evolution has stepped on the accelerator.
That's a really cool creature.
Predators have taken their first bite. This is Anomalocaris, Earth's first super predator. This 2-meter-long monster owes his success to a monumental evolutionary landmark. Eyes. They may look bizarre, but they're not unique. Many predators in the Cambrian seas have also evolved eyes. And so have their prey. The consequences have been explosive. Being able to see and react to enemies has triggered an arms race between hunter and hunted. This battle continues today and is a major force behind the variety of life. To combat being visible and vulnerable, 80% of creatures in these shallow seas have sturdy skeletons on the outside of their bodies. These armored animals are called arthropods. In the future, they'll give rise to insects and spiders. But in these crowded waters, there's competition everywhere, and even the mighty Anomalocaris' defenses are constantly put to the test. Rigid armor splits if bent too far, leaving the loser vulnerable to a completely different threat. This is Haikuichthys. He's the size of your thumbnail, but he's an evolutionary giant. He's the first ever fish.
Okay. And we'll talk about those more later. So Anomalocaris wasn't huge. Still would be kind of scary if you found one of those while you're swimming in the ocean, though. You wouldn't want one of those grabbing a hold of your leg. And that's where we're going to stop today. We'll talk about trilobites next week. So, okay, the polls are for a grade. You get one free question, but yes, they are for a grade. All right. If you don't have any questions, you're free to go. Have a good weekend, and I'll see you next week.